To reiterate, you're borrowing $10,000, you have a 15% interest rate on that loan. This tells me how much I'm going to owe in the simple interest case after how many years, and how much I'll owe in compound interest. Compound interest simply grows faster. So 15% simple does not mean the same as 15% compound. They mean two different things practically. We'll look at the formulas for compound interest today, but this is an interesting thing to study. So if you're the one borrowing money, and you have to pay it back later with interest, would you rather have a simple interest account or a compound interest account? Absolutely, you'd rather have simple because you owe less money. You owe way less money in over 20 years than in compound case. But if you're the one lending out money and someone's paying you back with interest, and so you're benefiting from interest, would you rather lend money at 15% simple or 15% compound interest? Now it's compound. If you're the one benefiting from the interest, you like the fact that it grows faster than simple. Let's go to some more extremes. Let's look at, what would this be, 30 years? After 30 years, you owe 55 grand in simple interest case, 10,000 of that to repay the loan, 45,000 of that is interest earned on the loan. How much do you think compound interest will be? Someone give an estimate, ballpark. Just thought, I guess, it doesn't matter. 300,000? Let's see. After 30 years in the compound interest case, you're going to owe $662,000. Yikes. Yeah. Because it's just growing so much faster than you can think. If you go out for 50 years, it's going to be wild. If you take 50 years to pay this back, in simple interest terms, you only owe 85 grand, which while that's a lot of money is not all that bad. You will have had the money for 50 freaking years. But if you go the compound interest rate, someone give me a guess. Throw out a guess. 3 million, let's see. You have 3 mil. After 50 years, you're going to owe $10,836,574.42. This is not BS. I'm not making this up. This is exactly how the math and the numbers work. So again, early on, compound interest doesn't look that much worse. After 1 year, they happen to be exactly the same. But early on, compound interest is bad. It's worse. But it's not like, breaking the bank absolutely. But as you keep going on, the differences between simple and compound interest just become radical, just totally radical. So obviously, compound interest sucks if you're the borrower. Here's the unfortunate truth. Here is the sad truth. Simple interest really doesn't exist in the world today in any serious financial sense. No institution is going to do simple interest. The exception might be payday advance loans. Payday advance loans, sometimes they'll say that's simple interest, but those have really high interest rates. Sometimes they have 300 to 500% APR per year, which is ridiculous, but payday interest loans are meant to be paid in a short time frame, so the interest is not totally fair. Pretty much any major financial institution today uses compound interest. There are mathematical reasons for it. Think about it like this. If you were an investor, you were putting your money into an account that got interest. If it was only getting simple interest, what you do is you put your money into the account for a year and you'd have more money now. You'd take that money out and start a new account, right? Because now the interest you're going to earn is on that updated higher amount. If you leave it in the same account and never change it, and it was only earning simple interest, it's only earning a % of the original amount you started with. Thus, you would take the account and you would have to update it every year and get a new account to really make more money. But since that's ridiculous, they just do compound interest, and secretly what you're doing is compounding interest anyways. So any major financial institution uses compound interest today. Now, there's a few good news things. Mortgages are at or nearly at an all-time low, meaning interest rates are really low. The reason is that the Federal Reserve lends money to banks, which banks then turn around and lend that money out. And the interest that the Federal Reserve charges the banks is low, and the Federal Reserve decides what that interest rate will be. But anyways, mortgages are at an all-time low. Interest rates are at generally speaking, are very low right now. If you need to borrow money, you can do it, it's said, cheaply, because you're not going to have to pay as much in interest. So there is some good news. Another thing is the example we did here in Excel. The example here in Excel, this assumes this example assumes you borrow the 10,000 and pay it all back at once a number of years later. This is called a lump sum. That's not really how it works, is it? When you borrow money for a mortgage, to buy a house, when you borrow money for a car, things like that, you don't really do it that way. What you do is you borrow the money and then you pay it back in installments, usually monthly payments over time. And so because you're doing that, you're knocking down your total interest that way than if you just let it simmer. So what's really going on here? What's really going on? We're talking about compound interest. Compound interest is interest computed on the original principal as well as any accumulated interest. So as it earns more and more interest, an account, the amount of more of interest that gets added onto it itself is going up. Simple interest, every year you put the same amount into the account in interest. That doesn't change. Here, compound interest is being updated because the account is being updated. We're not going to zoom in on this formula just yet. This is the general formula, but it doesn't quite have all the information we're going to want just yet. So we're not going to look at that formula too closely. But compound interest, the formula, just as a quick thing, that T there, earlier for simple interest, we put the T here, remember? 1 plus RT, we multiplied it. Here, that T is an exponent. It's being raised to a power. So it's just a different thing altogether. It's different. And hence, compound interest is said to have exponential growth. So we won't look too hard at that just yet. So let's break down this formula. This is the formula you'll want to kind of understand a lot better. That's the number 1. This is said to be the compound interest formula. This is for a lump sum, it's called. Again, this is not going to be the case where you borrow money and pay it back slowly over time. That's technically called an annuity. This is going to be the case where you borrow some money, you keep it for the whole time frame, and then you pay it back with interest later on. That's just a one-time payment going in and then coming back out. That's how it works, as opposed to an annuity. Again, notice the NT up here is in the exponent. Let's talk about what each of these things are. A is going to be the accumulated, aka future value. It's going to be the total amount with interest. It's going to be how much is paid back later. That's going to be in the future, how much are we going to owe? And it's going to include the principal and the interest earned. So that's exactly what it was for simple interest. We use the exact same variable, A. P is said to be the principal. That's going to be the initial amount, either of a loan or an initial amount invested. R is going to be the interest rate expressed as a decimal, just like last time. T, once again, is going to be the number of years. So those variables are all almost identical to what they are, pretty much are identical to what they were for simple interest. Our formula is just different now for compound interest. But there's one more variable in here, and that's N, and that's going to be the number of compounding periods per year. And I'll explain what that is in just a second. I'll give you a second to write that all down. The number of compounding periods per year, what happens is, let's say you're getting paid interest on your account and you have to wait till the end of each and every year for it. So let's say you got 12%. Let's say you got 12% yearly interest on an account. Normally, you have to wait until the end of each year to actually get your interest paid to you. That's kind of the normal thing that you have to do. Oh, I got to wait till the end of the year, and then I'll get my 12% interest paid to me. What if you wanted your interest paid quarterly, 4 times per year? What if instead of having to wait till the end of the year, you just have to wait till the end of every 3 months and you'll get some fresh interest thrown into your account? You could do that if you cut 12% into 4 pieces of 3%, and you get 3% interest every quarter. That's what it's talking about when it's talking about number of compounding periods per year. You can actually speed up when you get your interest, but you get less at any one time. Or you could have had it pay out monthly. Instead of having your interest paid quarterly, what if you wanted your interest paid out monthly, which is 12 times per year? You could then do that if you cut the 12% into 12 equal pieces of 1% each. And then you get 1% interest every month. So if you wanted to wait, if you wanted your interest now, you could get your interest at the end of every month if you instead agree to take 1% interest each month. You're still technically getting 12% per year, but you're getting it in pieces and you're getting it a little bit early. Doing it that way actually earns you more total interest in dollars faster. It earns you a little bit of interest faster. And so it's kind of interesting that accounts will do that, but some of them do. Whenever you pay an interest rate, whenever you buy a car and you're making monthly payments, what they do is they actually do cut your interest rate into 12 pieces. And then you pay a piece of your interest each month. So that's what N is going to represent. So it's A equals P, open parentheses, 1 plus you take your interest rate and you divide it by the number of times you compound interest per year. Then you take that whole parentheses and raise it to an exponent of N times T. So pretty fascinating. Compound interest is just completely different than simple interest. Oops. So let's try it out. Let's flex our math muscles here and try out this formula. You deposit $7,500 into a savings account that earns 6% interest. The interest is not going to compound yearly, it's actually going to compound monthly. How much total money will you have in the account after 5 years? Find the interest after 5 years. So let's try this one out together. So you're not borrowing money. You're not borrowing it. You are putting it into an account, and you're benefiting from the interest. Maybe the money is being lent out to someone else who's paying you 6% interest, something like that. Technically, that's kind of what banks do in a way. Well, let's remember our formula. A equals P, 1 plus R over N, raised to the NT power. Let's see if we can write out all the different aspects of our formula here. A, P, R, and T. A is going to be what we're looking for in this first question. How much money will you have after 5 years? In other words, how much total is in the account, principal plus interest? So A is going to be what we don't know. We're going to put a big, fat, stinking question mark. P is going to be the principal. That's going to be the $7,500 we invested. R is going to be the interest rate we're earning. Remember, we have to express it as a decimal when we're actually doing the math. So it's going to be 0.06. N is going to be the number of times interest compounds per year. The interest is compounding monthly. So what's N going to be? Well, you're thinking right. N times T will be 60. That's the total number of compounding periods that money will go through, because 12 times 5 is 60. But what N is just how many times it happens per year. Well, in this case, it's going to be 12 for 12 months. Very good. Yeah, but 60 is, you're thinking smart with 60, because 60 is how many times interest compounds total over the life of the entire 5-year loan. But N is just the number of times it happens per year. T then will be our 5-year time frame. So now let's plug these things into the formula. I'll show you how you can put this into your calculator if you are dealing with one of the two calculators I suggested. Well, now we know what R is. It's 0.06 over 12 raised to the 12 times 5 power up there, not 12.5, 12 times 5. Now let's talk about what you're going to put in your calculator. If you have the scientific calculator or if you have the graphing calculator, both of which can let you do parentheses and all that, here's what you can put. 7,500, open a parentheses, do 1 plus. I would open a second parentheses to do the 0.06 over 12 calculation. So it knows to do that. You close the parentheses for this part. You close another parentheses for this whole thing now. Now you need to raise it to an exponent. That's going to be the caret key on your calculator. And we want it to do 12 times 5 to get 60 and then raise it to the 60th power. So I'm going to put that into its own set of parentheses. So this is exactly how it will look on your calculator, parentheses and everything. Your calculator, if it's fancy enough, may actually raise it to the exponent and write it as an exponent, which is cool. But let's see. Obviously, you can't use your phone calculator on an exam, but I can use it right here. What are you getting? So we'll round it to 2 decimal points and we'll do 238. That's exactly right. We'll round this one to 2 decimal points because we're talking about money and that means we're rounding to the nearest cent. So it just makes sense. So that answers our first question here, right here. How much interest will you, or how much total money is in the account after 5 years? $10,116.38. Now, if you want to know how much interest will be in the account, we'll clear out all this. Oops. There's going to be $10,116.38 in the account, period. But the amount of interest you'll have, how can I calculate that? How can I calculate the amount of interest this account has earned? Well, what did we start with? 7,500. What do we have now? 10,116.38. The difference is going to be the amount of interest that the account has earned. So if I subtract off the $7,500 principal, that difference will tell me how much the account has earned. And so this is the amount earned. This is the interest earned. So by you investing your money instead of putting it under the mattress, it's called, where you don't have it invested, you earned $2,600 and some change that you would not have earned otherwise. Cool. So let's work a few more problems. Let's go mine your homework for some problems. Let's pull up your homework. I had it open, but it closed on its own.